Hello everyone, welcome to our ClimateSCOpe. This is the fourth of our series of the ClimateSCOpe. This ClimateSCOpe is organized by the Space for Climate Observatory in collaboration with the UN Office for Outer Space Affairs. My name is Anne-Claire from the UN for Outer Space Affairs. We are delighted to have you today. As I was saying, this is the fourth of the series, a series that started just last year, the second half of the last year. Our thematic of today is From Land to Sea, Exploring African Climate Adaptation Solutions. We will focus on how Earth observation initiatives from the Kenyan agencies, and we will have a presentation of the Kenyan agency shortly, and the SCOPE project, 3 SCOPE projects to be precise, are leveraging satellite data to develop climate adaptation solutions to address African challenges, such as urban or coastal resilience. On the agenda, the presentation of the Kenyan agency, followed by the SCOPE project Sea Smart, then eSafari and WACA-VAR. So without further ado, I see we have all our speakers lined up. This session is recorded and it will be available on the Space for Climate Observatory YouTube page just a couple of days after this webinar. And please, if you want to give us a feedback, please already scan the QR code on your screen. You can open the feedback already and give us your feedback at the end of the session. Thank you very much. I see that Jacques Matara from the Kenyan Space Agency is online. So please, Jacques, if you can open your mic and your camera, and your slides will be on the screen shortly. Thank you.
All right. Thank you, Anne-Claire. Thank you, everybody. Good afternoon. Sorry for joining late. I was trying to look for the link, but I'm here. My name is Jack Matara. I'm Deputy Director, Space Research and Innovation from the Kenya Space Agency. Also, one of the focal points for this course since we acceded to the charter. The other one is Faith Maina, who's not here. I'll take you through our presentation. Next slide. That is the scope of my presentation. And then, of course, the Kenya Space Agency, which is the corporation or like the organization that is the focal point for SCOPE in the country, was established in March 2017, and we have a mandate to promote and coordinate, also regulate space activities in the country, with 4 key lines of effort or aspirations in terms of, number 1, enhancing the utilization of space services and technologies to support decision across government, that is national, county, and state departments. We also keen on developing a national space capability for socioeconomic development, that is in terms of infrastructure and also in terms of human capacity development. And very important to us is number 3, nurturing our space economy so that we are able to use space for innovation and solving the challenges that we have, and ensuring that people make money from such initiatives. And then, of course, utility, enhancing the awareness of space utility across all of the government. Next slide, please. Yes. So these are some of our objectives, and I think this is important so that you understand where we're coming from. We might not be the ones implementing some of these SCOPE projects, but as a coordinator of the sector, we have the private sector, academia, the startups ecosystem, and all of government trying to enhance the utilization of space data, as I've spoken about in my previous slide. And that is where now the use of Earth observation for initiatives in SCOPE, especially climate action and resilience, come in. and that is why these strategic objectives are important. And I've spoken about the first one. The second one is the capacity that I've also talked about, and awareness, and also promoting the acquisition and effective management and utilization of this data across all these sectors. Let's go to the next slide. Yes, so as I said, we have agencies that are really the custodians of such kind of initiatives, but we support, especially with our expertise, with trying to build their capacity and with coordinating and bringing together a couple of stakeholders so that they can be able to work together on such projects. And part of what we've done is number one, for the ease of access of Earth observation data, for ease of access of even reports on projects that have been done for posterity. We established a geoportal where we are able to share spatial data sets, Earth observation satellite imagery from our partners, to make it available to students for research in different sectors, and also even to the private sector, and also to even government, especially county governments and other departments. So we, in that effort, this is a project that we did that started especially with giving a research grant to universities to develop an application for crop condition monitoring using AI and machine learning. And then, of course, graduated now later in the next slide, as you'll see, to an artificial information management, agricultural information management system that we've done with one of our counties, where we got more partners, Microsoft AI, Spatial Collective, and a couple other local stakeholders to be able to do that. And we've also been able to support county governments. About right now, out of 47, we've done 10 of them in terms of developing their county spatial plans. Next. And then these are some of the projects, especially using Earth observation, that are related to this particular conversation. The first one on my far left is forest cover, and that is natural resources management. So just, working together with a couple of stakeholders, each of them aligned with what you're doing, especially Kenya Forest and all those other organizations like, Water Resources Water Resources Authority that are concerned with the catchment areas in forests, and all that. We did a forest cover analysis with them, and also providing technical support, and also providing high resolution satellite imagery, and of course also using the available imagery from Copernicus catalog as well. And this is also part of the initiative that we're doing with the World Bank, that is also looking at sustainability linked financial framework, whereby we are doing reporting on our forest cover every year to help us to be able to get good credit to access some of these bonds and loans from World Bank. The second one is urbanization. Because of population pressure, we also worked with a couple of stakeholders, especially the State Department for Urban Planning, Housing and Development, and also the Kenya National Bureau of Statistics, among other stakeholders, to be able to look at some of the major cities that we have, looking at what kind of, activities are going around there, and looking at how we can be able to control our urbanization, making cities that are emerging and expanding more inclusive, smart, resilient, and all that kind of thing. The other one is on the far right is flood mapping, whereby we with the effect of climate change, we are mostly hit by floods in a lot of areas in the country, and we did a case study in the lower Tana Basin, where we were trying to come up with a flood hazard impact catalog and an early warning system, just to be able to enhance our resilience when it comes to flood mapping. And we also had a couple of stakeholders here: Kenya Meteorological Department, the Red Cross, the National Disaster Operations Center, a couple others, and also even representatives from the county, just to be able to work on that. It's a pilot that we are hoping to also be able to implement or cascade to other flood-prone areas in the country, and which we have many. Next. Yes. And on that, I think on research, this is actually where we are concentrating mostly, especially in trying to find those novel and innovative solutions to tackle the challenges that we are facing on climate change, on agriculture, on urbanization and urban sprawl, and also even on health. And we start these things, as I said, from the universities, because we have a lot of theoretical knowledge that exists there, and a lot of let me say, like, workforce that once given the correct kind of support and guidance, then they are able to apply their theoretical knowledge in solving most of the challenges that we face. And these are some of the projects. I know some of them might not apply for this, but that we've been able to sponsor, and that have been, it's not like an event, but it's continuous, one building on top of the other, like the nanosatellite development that started with a 1U, now they are doing a 2U, and also rocketry development. Space weather monitoring is another one that is very key. But number 3 now, that is where we are working on all those key sectors to provide solutions using EO and satellite imagery, just to be able to help support the government priorities in that area. And what we're also doing is the Africa Earth Observation Challenge that we are doing with our partners from across Africa, just to be able to support startups that are using Earth observation data and space technology to solve our challenges here in Africa on key areas like climate resilience, on things like dumping agriculture, food security, and those others. And we also are very keen on having, like, one of your 5 labs here, the establishment of an Africa Business Innovation Lab that will also be able to help us in doing most of this work on these areas. And then, of course, we are, as a way of working with universities, we also having innovation hubs situated in those universities, where students can do their attachment and work on joint projects together. And that has been very helpful, especially with universities. With Taita Taveta right now, we are working on mangroves, mapping and conservation, because it's one of the endangered species that we need to be able to protect. And Dedan Kimathi University, also with one such facility, is now working on the forest, the sustainability financial linked framework. And we will be engaging more universities, especially in a few other areas related, to all these particular areas. And then, of course, now we are with our GeoHub, we are looking at being able to make data available. Next slide. And then now these are some of the things that we plan on doing: technical capacity development in Earth observation, in using emerging and disruptive technologies, to get insights and to come up with solutions to societal challenges and those kind of things. We're also very hopeful of having a sovereign Earth observation satellite constellation to be self-sufficient when it comes to provision of satellite imagery for all these other sectors. We are also looking at spaceports. I know just to be able to, as a commercial facility where we can collaborate with a couple other players in the sector. And then, of course, growing the space innovation ecosystem is really key, especially on the downstream and on the upstream, in terms of development of applications. because then that is where we have, the biggest chunk of what we can do with the space economy in all these other sectors, including climate change. And then, of course, stakeholder engagement is key, because now we have things like the communities of practice around actually climate and disaster. That is one of the 7 COPs that we have, and they are meeting, or we are meeting regularly to just discuss projects that we can be able to do and how to be able to act on climate action and resilience and those kind of things. Next slide. Yes, thank you. That is the end of my presentation. I didn't know how much time I had, but I hope I've stayed within time. Thank you very much. I welcome any questions.
Thank you so much, Jacques. I think this is the perfect introduction for our webinar. Do you have any questions? And I'm talking to the audience. I didn't see any questions in the chat for now, but I do have one actually. So Jacques, I would like to know how, because the Kenyan Space Agency is working at the national level, so how do you make sure that your communities in Kenya are engaged and that their needs are fulfilled?
We have a very strong, let me say, like outreach department that I also happen to be lead. So we really have a team that has, structured engagement with the public, number one, with the students, all the way from elementary school to secondary school to universities. That is also engaging with our county governments, the sub-county, sub-national levels, and the county, to be able to bring these sort of, like utility of space and awareness of the potential that there is for decision support and for socioeconomic development to solve some of the challenges that we have across. So it is like, something that we're doing together with even other partners also in the sector that are also part of that team of doing outreach to other people in the country.
All right. Thank you so much, Jack. I see a question in the chat actually from Victoria. Do you see Earth observation partnerships as a way to strengthen long-term scientific cooperation across Africa?
Sorry, I got distracted by a call.
No issues. I can just repeat the question. Victoria is asking, do you see Earth observation partnerships as a way to strengthen long-term scientific cooperation across Africa?
Absolutely, 100%. I think with Earth observation for Africa is probably the lowest hanging fruit, especially in space. We are not so big on, I don't know, maybe engineering and constellations and satellite, what is it called, space science and astronomy, even though we are very good at astrotourism. But Earth observation, especially how it relates to the common man, how its value proposition for, like, agriculture, food security, for disaster, risk management, that continuous monitoring and those kind of, for planning, and a couple other things, is something that, most Africans are relating to and they are appreciating, especially, with space. And that has been able to, coalesce as, together, even with the Africa Earth Observation Challenge, even in our own, conferences, meetings, and symposiums. What we talk about is that collaboration, because then we have almost the same kind of challenges. It's food, it's disaster, it's planning, infrastructure, and those kind of things. And EO is what is coming out, like as the magic bullet to all these problems in terms of supporting decisions and informed decision making.
And this is also why the Kenyan Space Agency joined the SCO as a signatory, I think, just last year. So congratulations on that. All right, I don't see
very
any
much.
more questions in the chat, so I think we can move on with our scope portfolio. And for this, I'm going to hand over the floor to my colleague Alexia Fregnaud from the CNES and the Space for Climate Observatory.
Thank you very much, Anne-Claire, and thank you, Jack, for your presentation and the answer to the questions. So now, as mentioned, Anne-Claire, we are very thrilled to present 3 scope projects. The first one will be the SeaSmart project from the UK that is supported by the UK Space Agency and Space for Climate. Then we'll have the presentation from the eSafari project from Belgium, and we'll finish with the WACA-VAR project from France that is supported by CNES. So to begin, we'll start with the project SeaSmart. We'll have the presentation from the 2 co-founders, so James Doherty and Jack Lidley. So thank you very much for being here. Just maybe before giving you the floor, a few words about the project. So the SeaSmart project develops a climate adaptation tool for seaweed farmers and coastal stakeholders, addressing biomass health, biodiversity, and pollution threats. So Jack and James, over to you.
Fantastic. Thank you very much, Alexia. Yeah, it's great great to be here today. A great honor. Thank you very much for the invite to speak. Really enjoyed the previous discussion, and would definitely be keen to touch base with Jacques, especially around mangrove mapping, which has certainly caught my ear. So we're a Plastic Eye, and I'm really happy to present the SeaSmart project today. I've noticed I very much omitted a relevant SDG icon, and a lot of our work very much speaks to SDG 14. So we will be sure to add that after the talk. The focus of our discussion today will be on kelp. It's a really amazing coastal seaweed or algae which performs lots of really important functions, supports ecosystems, supports economies, and is really important to coastal resilience. So a really interesting topic today. And yeah, the project that we will be presenting, SeaSmart, has a focus in 2 areas of Africa. So right down on the south coast in South Africa, and then on Zanzibar as well. So looking forward to sharing details with you on this. Next slide, please. So as mentioned, we're Plastic Eye. We're a UK-based company. We've been around for about 5 years, and we have a focus on using Earth observation data to produce actionable water intelligence, and really we work across a number of different use cases to really exploit the benefits and advantages of satellite data. Next slide, please. We work with a range of fantastic partners from academic institutions, government agencies, NGOs, etc. So we have wonderful partnerships. And yeah, these are really integral to us being able to build what we build robustly. So to lay a little bit more foundation then on kelp, as mentioned, it's a macroalgae found particularly in coastal areas. It's a really important type of seaweed. It supports many millions of livelihoods around the globe, but it is being lost in quite significant quantities and in industrial times. A lot of this feeds into kind of climate driven problems and challenges. So water's not being quite optimized, or what the kelp has optimized to live in, pollution entering zones, but also overfarming is a real problem. So these kind of beautiful long stalks of kelp, which anchor themselves to rocks or to the seabed and then kind of float up to the surface, they can be harvested responsibly if they're cut off kind of above the point that attaches to the rock. But that's more challenging. So quite often when they are harvested, they're kind of cut off at this point of anchoring, and that means that the kelp plant essentially won't grow again. So this is one of the major challenges. The global seaweed market is very valuable at around $30 billion as well. So there's significant economic interest in maintaining the health of these ecosystems. Thanks, Alexa. So the monitoring challenge in this space, you know, generally, and you'll hear this a lot in Earth observation discussions, is that we can better manage natural assets if we can monitor them and make really data-informed decisions. Existing methods of monitoring these sorts of kind of coastal ecosystems often involve putting divers into the water, or maybe vessel-based surveys where there's sufficient budget. These are collecting extremely valuable and important data sets, but they do have their limitations. They can be quite expensive to deploy. Because of that, they're quite often deployed infrequently, so 1 to 2 times a year. They're generally geographically limited in their nature. So if you're aiming to conduct kind of coastal wide audits at scale, that's challenging to do, and again, extremely expensive, and they can also involve putting people in quite dangerous environments. And this means that there's a gap in the data which is fed to kelp farmers, where they're really keen to understand how biomass is changing, the health of the kelp over time, when is the most appropriate time to harvest, avoiding over harvesting, what are the real pollution risks in the area, and generally the biodiversity shifts as well with changing conditions related to climate change again. So there's a significant data gap which kelp farmers experience. So our approach using plastic eye and using remote sensing technology is we aim to fill that gap using Earth observation methods. We're using multi-sensor satellite data, largely in the optical due to the sorts of information we want to gather. But we do augment this in instances as well with drone-based data. Our smarts and intelligence as a company is very much in the analysis of this kind of big data challenge. So computer vision methods, etc. But also going beyond just the kind of the pure looking at the water environment. So we do a lot of modeling of, for example, nutrient runoff from catchment areas as well to get a better understanding of the actual water quality on the grounds. We distribute these insights both via our own web platform, the Plastic Eye Observatory, which my colleague Jack will give us a short demo of at the end of the talk. And then ultimately, we're aiming to grow what's a kind of global algae intelligence layer. And this is both looking at kelp and looking at the challenges around farming there. But also we're developing monitoring, reporting, and verification capabilities around things like seagrass, like mangroves, like tracking sargassum in the Caribbean as well. So we're aiming to build quite a large and ambitious and powerful tool. And just very briefly then to highlight what's the kind of real value of that for users of this data. Well, you're getting the advantages of satellite data, so very broad coverage in terms of geographies, high frequencies with very regular satellite overpasses. Generally, there's an order of magnitude cheaper than if you're undertaking ground-based surveys, but very much aiming to complement those. And then ultimately being able to measure the thing you want to measure, but then also this kind of piece of really understanding the water quality, which really feeds into the kind of the quality and the risk of the ecosystems we're aiming to measure. So excellent. So that's the preamble done with. So the SeaSmart project, we have looked at specific sites in Africa to develop this proof of concept technology. And here we, at a high level, aiming to create space-enabled, scalable and affordable tool that supports sustainable seaweed farming and coastal ecosystem resilience, especially for communities most at risk. So as highlighted, kelp is really, really important to communities around the world, but on the coasts of Africa. And again, can we provide affordable access, really useful information to support with nurturing and responsibly harvesting and farming these environments. So the most important part of this is, and absolutely the correct starting point is who we're working with. So in South Africa, we're working with Tourist Cape Kelp and AfriKelp. So these companies are involved with both the kind of farming and the harvesting of the kelp in South Africa. So this is Tourist Cape Kelp, but then in the kind of the conversion then of the kelp to useful products and the distribution of those, and that's the role of AfriKelp. So these hold the largest concession of kelp beds in Africa, around 800 hectares, 8 kilometers of coastline, I should say, in South Africa. And they're harvesting thousands of tons of kelp every year, and they're doing this using responsible methods. So they're not diving down, they're not cutting the kelp stalks, from the base, but they're doing this kind of, quite traditional kind of manual-based work. So using boats and harvesting the kelp from further up the plant to ensure it can grow and provide biomass for other seasons. When we've spoken to Tourist Cape Kelp and really got to understand their problems, so it's pollution, so mining, upcurrent, hotel runoff, shifts in coastal erosion, warming seas, and then a lot of grazers as well. So things like urchins as well, eating away at the kelp. And their role in this project will very much to be provide, lots of ground truth, but also the species knowledge. What are the insights they really do need to act efficiently and responsibly towards the kelp? And then our second partner on the next slide is the Zanzibar Seaweed Cluster Initiative. So this is a much kind of less industrial community working with lots of smallhold farmers, 1,500 plus farmers, the majority of which are female. And this is a really important source of income, support, nutrition, etc. around this part of the world. Some similar challenges, again, around pollution, warming waters, but again, like no existing environmental monitoring framework. So again, that it's kind of hard to know when the risks are coming and to make well-informed decisions around that. And again, the role in this project is providing really important ground truth insights and real world validation of what we're doing. Next slide, please. So while we're in the relatively early stages of this project, fortunately we've done a lot of parallel work, as mentioned, in things like seagrass mapping and sargassum mapping. So we're expecting to make extremely quick progress on this front, and ultimately the deliverables here are going to be a data layer which really supports decision making in this space. So mapping the extent of kelp beds, the health and the biomass indicators of the crop. What's the pollution risk matrix? Can we be providing foresight of pollution events to try and take mitigation efforts against those? What are the changes in the biodiversity? Is the seaweed looking like it should do at any particular time of the year? Is it ready to harvest? And generally making sure that you're not over harvesting. So planning, which areas are you going to harvest this year and in what quantities, etc. And then ultimately building up this kind of trend and analysis over time as well to better understand and refine these farming methods going forward. Next slide, please. And so ultimately what we actually want to deliver is either access to these insights via our existing platform called the Plastic Eye Observatory, or indeed API access, probably more for AfriCelp for integrating this into existing structures. We're really keen to provide as much education as we can, both around Earth observation and satellite data and the possibilities and how it can inform these approaches. So yeah, we plan to run a number of workshops around that. AI models that, yes, ultimately we're going to be training them for these environments, but can we scale these up and support industry at other points around the African coast and then globally, and ultimately, yeah, providing outputs which are going to support these industries, but also the wider goals of SCO and UN priorities, and we spoke about the SDGs, etc. So very much working using those as a framework of for goal setting as well. As I mentioned, we have developed this technology on around different use cases. So plastic pollution detection, you may guess, was our first application, but we also work in harmful algal blooms, in sargassum, in seagrass and aquaculture monitoring. So yeah, very happy to have discussions around those as well, as if of interest, and they very much complement what we're doing with eSmart. So I don't know if we have time now, because I've probably been a little bit verbose in my descriptions, but just a quick check with Alexa if we have a minute or two for a demo, or if not, happy to jump to Q&A as well.
No, you can have 2 minutes to present the platform. No worries. I can stop the sharing, and Jack, I think you can share your screen.
Great, thank you.
Thank you, Jack. Thank you, James.
I will just get up my screen sharing. Can everyone see that all right?
Yes, it's working.
Okay, brilliant. So yeah, I'll just quickly run through the Plastic Eye Observatory, which we have a number of different layers and use cases in at the moment. Unfortunately, the CSmart use cases is not in here, so I will be presenting some of the debris detection functionality that we have with a focus around the Ghana coastline. So the Plastic Eye Observatory is designed to very quickly and easily allow end users to look at large areas and time periods of interest and get quick insights on those areas of interest as well. So it works on a request basis where you select an area of interest and a series of times to get these insights back to you. So there's 3 types of request in here at the moment. The first is called a debris request, which essentially shows you essentially a running video of debris detections calculated by our model over time. The second one of these is called a heat map request, and this builds up a picture over time of detections, so you can understand where accumulations of debris are taking place. And then finally, there's a request called interactive detections, which allows the user to really dive deep into individual debris detections and understand the components of those detections. So I'll just quickly go through creating a request, although I do have some pre-made to just show all the different functionality. But we aim to set it up so you can very quickly draw an area of interest, like so, which is set for a certain size. You can then also select a start date and an end date for this. So I'll just quickly put some in here. And then give the request a title and send it off, and then our system will automatically go back and look at the satellite data that we have, or indeed request it if we haven't already looked at it, to produce these insights. Now moving to Ghana, where I can show some examples of these requests. So this is this is debris request. So you can see here it's showing a true color imagery of this area of sea over time, and where the satellite has, where the model has detected that there has been debris present, it will show up on here, highlighted in orangey red, which I think it did a little bit earlier on in this view. We can also look at this over time as well and see the number of debris detections over time in here, and this can be grouped by day, by month, and by quarter. And then going on to a heat map request. So this looks very similar, except it is just building up the detection pattern over time, and creating an understanding here of where debris detections are most commonly found in this region. And finally, going on to our interactive detections, we can see here that it is showing up some of the detections, and if you hover over them, you can see various metrics about each individual debris streak. You can also move through these over time as well, and it will show the various detections. And an additional insight we offer here as well is the ability to forecast where these detections are going to go, which can be useful for cleanup operators or for policyholders wanting to understand where this plastic may ultimately impact the coastline.
And for seaweed farmers, I'll add there as well. So plastic can be a major risk for mechanical damage to what are relatively kind of delicate crops. So it's very much relevant from that perspective. Yeah, absolutely. And so I can just show an example here of a debris forecast. So this is one of those large debris instances, and you can see here there's essentially a blob with increasing levels of certainty the further out you go, and this is propagated forwards over 3 days. And in this instance, the majority of this debris impacts the coastline just along here. And yes, that is a very quick run through of the platform. Very happy to have further discussions or a more in-depth demo as well.
Thank you very much, Jack, for this presentation. If you do have questions, please, you can ask them on the chat. From my side, I had actually 2 questions. The first one was, are you working with African space agencies? Because you mentioned that you were interested, for example, in working with the Kenya Space Agency. But for example, are you working with SANSA from South Africa? Do you see any interest in developing these partnerships with the space agencies?
Myself, at this point, no, sadly, but we'd be very much keen in exploring those partnerships. We've worked very productively with the European Space Agency, UK Space Agency, Canadian Space Agency, etc. So we've got a good sense of the benefits flowing in both directions from collaboration there, and we'd be very much open to exploring collaboration at a broader scale as well. So if there are opportunities to make connection, we'd welcome them.
Yeah, I think the SCO can completely help you in connecting with these other agencies. So there are 2 new questions. The first one from Niels. Which satellite data is used?
I can let Jack pick that one up.
Yep, happy to answer that one. We use a blend of primarily optical satellite data, a blend of open access and commercial imagery. So a lot of the data products we presented today were derived from Sentinel-2 imagery primarily. We also use Planets and Vantor imagery as well, although as that is commercial, there is a cost element associated with that. So we tend to do large area coverage with the open access data, and then zoom in on key areas of interest to deploy commercial satellites.
Thank you for the answer. We do have another question from Eric. Are you tackling harmful algae blooms as well? With which satellite sensors?
So that's a great question. We've developed substantial capability around harmful algal bloom detection and forecasting over the past number of years. We've worked with the Department of Environment and Agriculture in Northern Ireland on Lough Neagh, which sadly is well documented to have some of the biggest bloom challenges, particularly over the last kind of 5 or 10 years. So we've developed quite a sophisticated capability around doing historical analysis, but also forecasting when and where the blooms are going to occur based on environmental drivers. That is obviously been focused on freshwater. Lough Neagh is a freshwater water body, largest lake in the UK and Ireland, and we are expanding that and testing and validating and recalibrating these models across, at the moment, water bodies in the UK and Ireland. But we are also starting to test and expand this into coastal areas. It'll be really nice because it'll be a bit of a fusion of the approaches that we've developed in these freshwater zones, and combining that with some of the capabilities in coastal zones and understanding flow modeling, etc. as well. And we know that these harmful algal blooms and red tides in coastal areas can be pretty devastating for like aquaculture, for tourism, really significant economic, financial losses of livelihoods, etc. So we're very much keen to continue expanding, our capabilities in this area. And on which sensors we're using, probably very similar to what Jack mentioned in the previous answer there. So mainly leaning on the optical, because we're these kind of greens and reds are really the key colors to be extracting, and the key signature. But don't know if Jack wants to add anything there.
Yeah, just quickly, broadly the same set of satellites, with the addition of Sentinel-3, which is very well optimized for looking at algal blooms, and a little bit of synthetic aperture radar satellites as well. So a mixture again between Sentinel-1 and the ICEYE satellites for that.
Thank you very much for your answer. We do have another question, just very quickly, because we are running a little bit late. But could you confirm that the fisherman community consults the applications before going at sea, for example, the weather?
Yeah, so it's certainly our intention that this kind of information, can be accessible to make those sorts of decisions about. We've kind of thought about this a lot as well when we're considering the movement of sargassum, because sargassum can actually be a hazard to boats themselves, and the boats, sargassum gets tied around the outboard motors, etc. So that's really important for navigational purposes. But also where the vessels are traveling, where they're navigating through, where they're dropping their anchors, or potentially, where they're in shallow zones. Are there any important ecosystems in those areas? So from seagrass or from kelp, and indeed we've had a really good collaboration with the University of Florida, seeking to identify where vessels are scarring seagrass beds as well. So through this project and through the connections of Afro kelp and Torres Cape kelp, we would hope to make those connections to the fishing community, and to put some of these insights in their hands, which are the most relevant. So absolutely.
Thank you very much. There is one question from Eric, but if you could please answer on the chat because we are running a little bit late. But thank you very much, James and Jack, for the presentation, for the demonstration, and also for answering to the questions. It was very, very interesting. So thank you very much for your time. Now we are moving to the next project, which is the eSafari project. So we are very delighted to welcome two people from Vito. So Koen de Ridder, who is senior researcher at Vito, and Niels Soevereins, I'm sorry for the mispronunciation of the names, who is climatologist at Vito. They will both present the eSafari project, which is an online dashboard for Niamey in Niger, providing urban climate indicator maps to highlight the potential of urban trees as an ecosystem-based adaptation measure against excessive heat. Thank you very much to you for being here. The floor is yours.
Thank you, Alexia. So Niels and I will be presenting together. I'll take care of the more generic aspects, and Niels will dive into the more technical aspects of the project. So eSafari stands for Ecosystem-based Adaptation to Future Heat Extremes in African Cities. It is funded by the Global EBA Fund, where EBA stands for Ecosystem-based Adaptation. And in fact, Global EBA is managing funds from IUCN, UNEP, and some German state funds. So it's a broad scope, let's say, from that perspective. Niels and I were from Vito, which is a research institute in Belgium, a bit like INERIS in France, I think, or TNO in the Netherlands. And in this project, we collaborate with ACMAT, which is the African Center of Meteorological Applications for Development. For those who know ECMWF in Europe, ACMAT would be more or less the counterpart, but with not the means that ECMWF has available. And as a third partner, we have Jeunes Volontaires pour l'Environnement. That's an NGO. The ones we're working with are based in Niamey in Niger, but they have several different locations where they're active. I think they're all together in like 14, 15 countries in Africa. Now, the main objective of our project is to generate scientific knowledge, or it's not just scientific knowledge, it's really creating evidence of the cooling potential of urban trees. Can be strange because everyone knows that trees are cooling, I guess, and that standing in the shadow of a tree is cooler than being in the full exposure of the sun. But still, we see a lot of added value in trying to quantify this. It's also a means or a sort of a tool you can provide to local stakeholders to claim rights to get additional greenery in under-greened city quarters, for instance. I mean, if you can show it clearly, scientifically, what the difference is and quantify this, then it has, we think, more value. And at least it appears to be an appreciated sort of type of information in African cities. So yeah, I mentioned this already. We are working in Niamey in Niger. We're building a dashboard. It's not ready yet, so we're just not even halfway in the project. And the dashboard is being developed now, and it will be ready in a few weeks or a few months, but we have nothing to show yet in terms of a demo. Okay, so we're ongoing now. We're about midway. At the end of June, we'll be halfway the project. Now, the challenge is about extreme temperatures. In Niger specifically, they suffer a lot from extreme heat. A few days ago, we had a project meeting with the colleagues from Niamey, and they were complaining about 43, 44 degrees Celsius temperatures. And as you can imagine, climate change is not going to help there. It's only going to get worse. We're trying to anticipate this a bit and try to see to what extent urban trees can counteract the expected or the projected heating. Another aspect that is relevant in this context is that as everywhere in the world, the more deprived communities, they have access to less green, typically. And so they have less benefits from the cooling aspects of green. So there's also an aspect of climate justice that is playing to some extent. And so in the project, we basically focus on generating information about the cooling power of urban trees. And we do that by looking on the one hand at modeling, and on the other hand, we also conduct local measurements with specific data loggers to capture this effect of the cooling of urban trees. And maybe just to point out the importance of climate adaptation in cities in Africa. As you may know, Africa is the fastest growing continent in terms of number of inhabitants, and especially cities are growing terribly fast. We've made some projections specifically for Niamey, for instance, and then you see that between 2018 and the middle of the century, they could like almost increase by a factor of 4 or 5 in just a few decades. And so you can imagine that, it's really important to account for climate adaptation and hopefully also, I mean, one of the things we try to achieve here is to provide information to urban planning organizations so that whenever they plan new city quarters, they can account for urban greening and as a climate adaptation measure. Next slide, please. Yeah, and so basically we have 2 phases in the project. And the first phase is now coming to an end. It's about creating evidence based on monitoring and modeling. Monitoring is going on right now. So the colleagues in Niamey, they have teams in the field where they measure. Typically, they conduct measurements in pairs, where they have one data logger in the full exposure of the sun and then another one close by in the shade of a tree. And so we simply measure the differences. And you can see an example on the right from a past project where you can see that the heat stress between a shaded and a sunlit position can be quite dramatic in terms of the amount of heat stress that it's causing. And then we do modeling, and that's where the satellite data come in, and Niels will explain that in a minute. And in the second phase, which is starting this summer more or less for the second year of the project, second phase will be focusing more on enabling uptake of ecosystem-based adaptation. So reaching out to different kinds of stakeholders, both the more official ones, as the policy makers, for instance, as well as reaching out to local communities, neighborhoods, and especially also schools. And we have good connections with an existing network of climate clubs in schools in Niamey. So that's an existing network, and we can make use of that network to bring in this evidence and knowledge on urban greening. Next slide, please. And I think now I should give the word to Niels to explain more.
Yes, thank you, Koen. Also, welcome from my side. So, as was said, I am a climate researcher in the team of Koen, and I've mainly been executing some of the modeling work that provides the evidence of the tree cooling in Niamey. And one of the things that we want to show in this work is to get an overview map for the whole of Niamey, so that everyone can see for every location in the whole city, for both the present day and the future, how heat stress will be affecting their neighborhood, so that we can see differences between areas, differences between neighborhoods, why these differences are there, and how this can potentially be tackled. So if you want to demonstrate the future cooling effect of these trees, you need these very high resolution, in theory, meter scale climate data. And luckily we have this kind of model available at Vito. So we have a meter scale climate model that can generate or model how heat stress is occurring in your city. But it only works if you really have this very detailed information or description of the land surface available. So in the last year, I've been working with satellite information for quite some time now, but in the last years there's really been a boom in satellite information that has become available at a global scale. So on the left you can see, for example, ESA World Cover. This is a product that was developed also by colleagues here at Vito. So 10-meter map of the globe with different land use classes, as you can see, which gives a nice idea of how your city or how your land use is looking in a certain region. And on the right, you can see a snapshot from the global human settlement layer, which provides very detailed information also on the build-up surfaces, and also provides an information about how cities have grown from the past until now. So they also provide historical evolution of data. Next slide, please. Like I said, you also need, like, this is nice at 10 meters, so the Sentinel data is usually used to achieve this information. But we want to go to an even more detail that is present. We want to get the individual buildings in there, the building height, the individual trees, we want to detect them. And lately there have again been some new developments in here. So new global products have become available, combining commercial satellite data, LiDAR, and the open data from Sentinel, for example, to get really a detailed view of where these trees are, where the individual buildings are. So even for cities where you might think there is no data available, like in the African context, you can find really detailed information about trees and buildings. So on the left, for example, you see tree canopy layer, really at meter scale resolution, identifying where the trees are located, including their height. And on the right, you see a product from Google, the Africa Buildings 2.5D model, which gives an idea of where the buildings are located, and the height of the buildings is also included. So the greener or the redder the color, the higher the buildings are. You can already nicely see on the left that the trees, that they are really located in a specific area in Niamey, so mainly near in the city center and near the river. You see a high abundance of trees, while more to the outer skirt areas where more slums are located, for example, less trees are available. So next slide, please. So here you can see a zoom of, we zoomed into a specific area in Niamey. So if you go to the next slide, Alexia, you can see how, you see there, we see the buildings and the trees from the satellite product overlaid. So you can maybe go back and forth a few times, Alexia, to showcase how this looks like. So you can see where the buildings are located are in red. The redder it is, the higher the buildings, and with green is the same for trees. So it's really a detailed view that is available over the whole of Africa with Google Africa Buildings, and also the tree canopy layer. So you can get really into very high detail. Next slide. So here you see the two maps again, and that is what we put into our climate model. So at Vito, we are really specialized in modeling the urban climate, so really taking into account the urban heat island effect. For example, the street layers, the street corridors that are available, we can model them in very high detail, and we can visualize heat stress then in a certain area for a certain time period. And that is what you see on the right. Here we have output from our climate model for a certain period for a certain day in summer, and you can immediately see the cooling effect of the trees. So you see underneath the trees, heat stress is lower, but what you can also see is that in the vicinity of the trees, there is like a cooling layer. You see the downstream impacts also of trees, where you see that they have a cooling effect to the areas in the vicinity of the trees, while in the center of the image, where you see almost no trees but more buildings, it is much more higher heat stress levels that are achieved there. Next slide. So, like I said, we didn't do this only for the present day. We also tried to do a future projection of how the city will look like. So we had to make projections of how the buildings will, how the city will grow, both with respect to buildings, but also with trees. So based on measurements from the global human settlement layer that have historical growth patterns of the cities, we made projections of how the city would look like towards the future. And we developed a new technology that can have place individual buildings and individual trees in the city for the future. So if you go to the next slide, you will see again a difference map. So you can go again back and forth a bit, so you can see how the city will grow towards the future with the individual buildings taken into account. Go to the next slide. Indeed, yeah, and then we can also see, we can run our climate model again and see how this will change the heat stress towards the future. So this is for 2050 for an average warming scenario. You can see that there is very much a strong increase in heat stress that will occur in Niamey. The trees will still have a cooling effect, but you can clearly see that they will be less efficient in cooling the area compared to the present day. So there is a clear limit to adaptation that is present. So in the next phase of the project, we will make this available for the whole city of Niamey, these maps, and then also in a dashboard where people can look around and go to individual city quarters. Next slide, and I hand over again to Koen.
Yeah, so I think one of the questions was also about stakeholder and user engagement, and that's an important aspect of our project. As I mentioned before, we have basically two sorts of target stakeholder groups. So the more official ones are like the Conseil National pour l'Environnement, le Développement Durable. So that's a sort of state office where they are also contact point for climate financing and green climate fund sort of stuff and all. And they're also in charge of the NAP and the NDC, so the National Adaptation Plan and the Nationally Determined Contribution, which are policy documents at national level where countries explain how they will tackle climate change, not only mitigation, but also increasingly adaptation. And our hope, or at least the effort we're doing now, is that through interaction with them, we try to get urban greening and ecosystem-based adaptation high up on their agenda, hopefully to include them in future versions also of these important policy documents. And then, yeah, as I said before, we have these climate clubs in schools. So there we really will go and meet them and explain the things we've been doing. They will, like the students will be allowed to play around with the dashboard that we're building. So they can zoom in and check for themselves what the effect could be of tree planting. And so we also hope that this will inspire them and motivate them, maybe to become a climate scientist one day themselves. You never know. And another aspect that is maybe not so clear for the moment is, but we have these measurements. They are conducted by teams of volunteers. And that's also a way of reaching out. We've been doing this in past projects as well, also in Niamey, but also in Johannesburg, for instance. We see very strong motivation also from these volunteers. Whenever they conduct measurements by themselves, I mean, that's the best way you have to learn about your environment. And so most people, they keep coming back and offer a role in these monitoring campaigns. And on the next slide, please. Okay, so Outlook, as Niels showed, we're building meter-scale climate modeling maps that will find its way at some point in the dashboard, where dashboard will be open source and people can play around with it and hopefully find the inspiration in there. And then, yeah, the outreach to policymakers and schools, that is something that will take off in July, basically. So that's for the coming year in the project. And I think this is the last slide. Yes.
Thank you very much, Koen and Niels, for the presentation. I saw that, Niels, you already answered to one question. We do have another one from Eric as well. Unsure of my understanding, are you using satellite data to measure the temperature of Niamey at meter scale? If yes, which channels are the most relevant? And if no, does it mean that satellite data are only used to detect the tree positions and that the cooling effect is only given by models?
Yeah, so it's the second thing that is mentioned. So we use the satellite data to characterize the surface in very high detail. So to detect where are the trees, where are the buildings, and that is then fed into our climate model. And the climate model is a real physical climate model that determines then what the temperatures will be in the vicinity or under these trees, near these buildings, taking into account shade of the buildings, thermal properties of the streets and of the buildings. Yeah.
And to add to this, we would be very much interested also in having access to meter-scale thermal infrared imagery from satellites. But as far as I know, that does not exist for the moment. I think currently EcoStress with 70-meter resolution or so is the finest detail you can get in thermal imagery. I think there have been some attempts to launch high-resolution instruments, but as far as I know, they're no longer working. But that's something that would really be an added value of having like meter-scale thermal infrared imagery.
Maybe one last question from Eric, and after that we'll have to move to the next project. So if you have any other question, please ask them on the chat and they may answer on the chat. Would a direct measurement of temperature from space be useful?
Yeah, it would be useful, and as I just explained, and in fact, we're using thermal infrared imagery for larger scales. We also run the models at a few 100-meter resolution, and there you do have like a satellite imagery that can be compared with. But then you have all sorts of other issues, like the angular effects versus the model temperatures. So there's a lot of work to be done still, I think. But it would be definitely interesting to have meter-scale thermal infrared data, yeah.
Thank you very much, Koen and Niels. I may have a question, but I will put it on the chat. And again, if you have any other question, please ask them on the chat. And maybe you can provide a contact detail if you're interested in receiving more information from Niels and Koen. So thank you very much, Niels. Thank you very much, Koen, for this presentation. And now we are moving to the last project, which is the WACA-VAR project. So we are very delighted to welcome Raphaël Almar, who is a research director at IRD, the French National Institute for Sustainable Development. So as I mentioned, he will present the WACA-VAR project, which is a West African coastal resilience project using satellite data to address climate change impacts and support coastal risk management policies. Please, Raphaël, the floor is yours.
Thank you, Alexia. Thank you for the invitation. So basically, you described already this slide, and I just want to stress that this project is between two collaborators, like a Public Institute for Development and also like a engineering company that developed a solution to protect the coast, Aegis, with Christophe Brière. The next slide, please. So WACA-VAR is about like a big issue that face all the coastal countries in the world, but particularly Africa, which is the most sandy continent in the world, and West Africa with low-lying areas, sandy beach, estuaries, mangrove, and they faced with climate change and sea level rise, erosion, flooding. And the issue is that there's not so much like in situ network of observation. That's particularly true for West Africa and Africa in general. And so it's a perfect place for satellite observation with regular revisit. And it's also like a so if there are some data, it's difficult to share them with decision makers. So one of the objectives of this project is to digest a bit this Earth observation complex sometimes data, and to make like a simple indicators of risk, so they can be better used for planning and coastal management. Next slide, please. So the SCO WACA-VAR is part of a broader program, interdisciplinary, on all kind of coastal vulnerabilities in West Africa, and started in 2019, 7 years ago. And so the SCO brick aim at using better like Earth observation, but completed with in situ data, and to produce two kind of product like all. So we are testing it we want to test innovative method, to develop new method, not to only use method and product. So we want to monitor basically what's happening. So like on the example here on the sand spit in Senegal that is developing over time. So to monitor shoreline, topography, but also like sea level and waves. And we are working at two different scales. regional scale from Mauritania to West Africa and Central Africa to Cameroon. And also we have two local hotspots, Saint-Louis, Senegal, and Dansoman in Ghana. And we are to disseminate this result. We are working on a web platform, and we are also discussing with like agencies, as I will show after. Next slide, please. So because we want to monitor a lot of variables in the nearshore, we are using several satellite missions, mainly optical missions. So regular revisit and also on-demand mission like Pleiad or Venus, even that can be daily at some spots. And we want to provide like a high-resolution product. As you can see on this, like on the lower figure, like you can see the comparison with drone topography and Pleiad Neo derived the topography with the tool of CNES cars. So this is validated here with like a topo from a drone, but also we have for the bathymetry a bot drone that was like used by our African partners in the University of Cape Coast, the ACE-Core Center, to validate and calibrate these products. And next slide, please. We at the local and regional scale, we have used like recently developed a tool like S2Shore, satellite to shore, that inverse bathymetry, coastal bathymetry from waves. So we sense waves and we inverse the depth, the bathymetry. And we have done like the full regional West African bathymetry at 100 meters using Sentinel-2. And so you can see on the lower panel like how it can improve the resolution of like channels, any sound like features compared with the existing on the right. So on the left is S2Shore, on the right is the existing bathymetry from gravimetry that is a bit coarse. And also we are now we have the 50-meter resolution shoreline along the West African coast also that will be shared on the platform. Yeah, next slide, please. Our objective, like overall objective, is really to have most information we can get from satellites. So not only bathymetry, topography, or shoreline separated, but to reconstruct the continuum land-sea from satellite, as you can see here for Saint-Louis. To capture like changes in and to monitor volume also of to have basically a DEM that not includes the land or the sea, but the two of them to be used after for coastal solution and manager and planning, as you will see after. This is an example here, for example. Next slide, please. So as an example of application of this satellite-derived DM by our engineering partner, Aegis, they estimated like based on satellite-derived topo bathymetry. So they estimated like potential coastal flooding with different scenarios, and they propagated waves on the bathymetry using a coastal wave model. And then they estimated like the elevation inland, as you can see on the two flooding maps with the blue, that is a flooded area with different like DMs. And on the lower panel also, they used our satellite DEM to apply like a beach change model, an overtopping model, X-beach, to design the level of protection needed at Saint-Louis. So including the uncertainty we have on satellite, which can be large compared with in situ measurement. Thank you. Next slide, please. And at the regional level, we are working with the West African Coastal Observatory that counts like 14 countries, I think, and with a pilot site and a representative in each country. And they have specific transect they monitor everywhere. So with them, we have developed a coastal vulnerability index that is multivariate. It includes a lot of driver of risk, wave, sea level, shoreline retreat, etc. And the type of coast, is it sandy, mangroves, etc. So we have developed that. So basically, it's simplified. So the manager can identify like hotspot of risk and identify the main driver of this risk and take action. And on the platform, so you can see after. So basically, red is risky and green is safe. Yeah. And the next slide, please. And on the platform that we are currently developing, we'll show this a time evolving like a value of this indicator with all the maps of a driver, wave, sea level, etc. And it's to show basically the temporality of this risk, and to also understand this risk with how the monsoon affect the coastal vulnerability and flooding, how the climate mode affect the interannual variation of this risk, etc. To understand a bit more that, and toward like a seasonal forecast of this risk also that can be used for for mitigation basically. Next slide, please. And of course, we are working strongly with this regional, so Orloa, which is the regional observatory of coastal West African coast, but also NGOs and national agencies. And we organize regular workshops in different countries. Now we have done 6. And with that comes with like a dissemination of results, but also perception of the risk by communities and agency, and training on satellite tools and product, like how to get bathymetry, how to get a shoreline, how to get a topo from satellite. And yeah, so I think it's my last slide, so I'm happy to respond to any question if we're a bit late already. I don't know.
Yeah, we can have 2 questions, I think. I open the chats. I have a question. Is the platform you mentioned already fully available or not yet?
No, it's a test phase now, and it's not publicly available, but it will be done. We are in the last year of the project, so it will be released later this year.
Okay. And you also mentioned the WACA program, the WACA program. How is it implemented within this program? What is the program more broadly providing?
Well, WACA is a program from the World Bank, and us, based on that, it's more working on solutions. WACA program of the World Bank, and based on that, we decided with all the academic and public operator in the region to develop knowledge. So it's the framing with the WACA program is basically we develop knowledge and we use this knowledge to help solutions.
Yeah.
So this is an academic program, WACA-VAR, and WACA is an engineering program.
Okay, very clear. Are there any questions on the chats for Raphaël? There is one question from Eric. What is the revisit time that you have today with your optical satellites, and that you would need if you don't have this revisit time?
The revisit, it depends on the satellite. Basically, if it's publicly available satellite, so it's between 5 and Sentinel-2, 5 and 10 days. Now, on-demand satellite, we set a tasking acquisition every 6 months at our hotspot, and Venus satellite, which is a French satellite, it was every day, but it was only over 1 year. And so basically, if we want to monitor, like, if we want to go to the event scale, of course, like 10 days revisit is not enough. Even more in West Africa, because we are in the tropic at the equator, and it's mainly clouded during the wet season. So it's a clear lock for optical satellite. So we are also working on a fusion between radar and optical satellite, like Sentinel-1 and Sentinel-2, to monitor the shoreline in particular, but also bathymetry and topo. And now, yeah, with other satellites. So the fusion of multi sensors can be key here to increase the revisit. Thank you.
Thank you, Raphaël. I do have another last question, maybe. You mentioned that you're working with agencies. Are you working, for example, with ACES in Senegal, the Senegalese Space Agency, and with other space agencies on the West Coast?
We are not working with space agencies. We are working with like managers, coastal managers, and the West African Coastal Observatory. So I think it can be good to make the link with the space. I think we discussed a bit that earlier with some partners. It can be nice to make the link with national space agencies. In particular. Yeah, definitely.
Well, I think there is no other questions. So thank you very much, Raphaël, for your time and for the presentation.
Thank you.
So maybe our webinar is coming to an end. So I hope you all enjoyed this webinar and learned many things from our speakers. Maybe just before closing this webinar, if this webinar was of interest for you, we would like to announce the SCO World Virtual Congress that will take place in November during the second week of COP31. As the name mentioned, it will be virtual and it will be worldwide. So we'll have several sessions, around 10 sessions that will be spread over 1 week. And they will be on different time slots so that everybody around the world can access to these sessions. So the communication has not started yet, but please stay tuned to have more information on this Congress. We will communicate as soon as we can on this event. And again, if you're interested in receiving any information from the SCO, you can still go to the SCO website and ask to receive the SCO newsletter and the latest updates of the SCO. And Claire, if you want to say a few words to conclude this meeting.
Yeah, thank you. I think it was a very rich session and exchange, because I also saw in the chats that our webinars are so generated some exchanges of contacts, and this is exactly why we're doing these webinars, for you to allow exchange of contacts and know each other, so you can connect. So this is really great. I think that was really a very comprehensive session. We have learned a lot about African climate adaptation solutions. So I think the title was really appropriate here. From land to sea, we've seen indeed how Earth observation can be useful for heat absorption and urban planning, for instance, but also coastal resilience. So I think you really enjoyed our presentations today. Thank you so much again for your participation, and we hope to see you soon at our next ClimateSCOpe, which I believe will be in October. So stay tuned and have a lovely end of the day.